Hello everyone, I welcome you to this activity. In this activity, we are going to build on what we covered off in the last section regarding image classification. So in the last activity, we covered unsupervised classification where we worked through k-mean clustering, and we are going to add to this, and this time around we're going to look at supervised classification. So this is where you, the analyst, you are going to take full control of the process by collecting ground truth data, or what we sometimes call training data, and then you are going to use that for the computer to be able to classify every pixel in the image. So at the end of this activity, you should understand land cover classification system, and also be able to manually sample and label pixels. So this is where we think of it as you going out to the field with maybe your GPS unit, and then you sample sites and then you label those sites or the land cover dominating that site. So we're not going to go to the field to do it, but we're going to do it manually or on screen by collecting pixels and labeling them. Okay. And the other thing we're going to also consider is classification using two supervised classification methods. So the first one is going to be the classification and regression tree method. And then once you have done that, we also explore random forest method just to compare the strengths and the weaknesses between these two methods. Okay. So we are going to follow the conventional, or what I would say, standard classification, land cover classification system. So this is where every pixel in the image is going to be classified as either a natural terrestrial vegetation, just like here, or is going to be a natural aquatic vegetation when the pixel is dominated by these surface types, or it could be a natural bare surface. So we're also going to classify pixels as natural bare surfaces. And then, or we may have another class called cultivated terrestrial vegetation. And then where you have got developed, urban areas, this is essentially, or maybe streets and roads, we're going to call them artificial surfaces. Then we are going to have water pixels also labeled or classified as water. So essentially, we're going to deal with at most 6 classes, and some of these classes can be merged. So we're going to explore that also in this tutorial. Okay. So the last time we looked at clustering, so where you are given an original image and then you let the computer, to cluster the pixels into homogeneous units. That we call clusters, and we explore the k-mean clustering to do that. So this was the results, and today we're going to build on it, taking this same image, but we are going to follow supervised classification methods. So we are going to use the CART classification, so classification and regression tree algorithm. We're going to follow that, and we are going to produce something like this. And then we change from that to random forest classification, another supervised classification method. So in this case, we're going to run two supervised classification methods, and we see that they produce dissimilar results. And then we try to assess their strength. We see which one is giving us better accuracy. So we're going to do that in this tutorial and also the next one. Okay. So when you open up your Earth Engine, so in this activity, we have been given two data set to start with. The first one is the steady area geometry. So this is our steady area. And so once you are given a steady area, it means that you are not going to necessarily use the whole image. And then, so we have got our steady area given to us, and then the next item we have is the image that we are going to use here. When you see this, that means that it's an image. So we've got the image to analyze, and then the study area to which to focus on has also been given to us. So the next thing we are going to do is that we are going to print this variable. We're just going to print this variable. And why do you want to print it? You want to see the number of bands in this image. Okay, the image has been given to us, but we don't know the number of bands in the image, so we're going to print that variable. Once you print that variable, it appears in the console here, so just wait patiently. And then we explore this image last activity when we looked at a supervised classification. So 26 elements, so you just open up and then you see the band. So what we're going to do is that we're going to select the relevant bands, and then I'm going to trim the data down. So the next thing is that we're going to select the relevant bands. Okay, so we're going to select relevant bands. So select bands. Okay, and then we cover that already. So we're going to use the select method to select this band. So we're going to run that, and then the bands will be selected. And then once we're not going to use the whole image, we need to also trim the image to the study area. So the study area has been given to us as well, project area. So the next thing we're going to do is that we are going to clip this to the image. So we're going to clip the image to the study area. So we're going to clip image to project area. So this is a project area. So we're just going to do that. So once you just use the clip function, that is all going to be, your image is going to be trimmed down to your project area. So I'm going to run that. And so you go the image trim to selected bands and also trim to your study area. So now we're going to do the next thing. The next thing is going to be, now we want to visualize. So we need to always visualize the data. So we're going to visualize the image. Okay, so we're going to visualize the image, and we've covered this. You have to use this workhorse, which is the map.add layer. So that is what we're going to use here to visualize. So I'm going to run that, and all of this thing has been covered in previous videos, so be sure you watch them. And so so this is my image here. So this is going to be the image I'm going to work with, because the image cover the extent of my study area. So I'm happy with this one. I'm going to progress to the next thing. Well, the next thing is that look into your image and see the surface types you have there. And in this case, we are interested in the dominant surface types. So you see a water body. So we're going to have one class called water. And then you see a lot of natural vegetation in the site. So we are going to have natural terrestrial vegetation. And then you may see some other site or surface types. So for this example, this is artificial surface, because it's a mine. It's a mine here. Could be artificial surface. We could also have paint, vegetation, and bare soils, and also other potentially cropping areas in that image. So you can see the surface types in this image, dominating the image. So what we're going to do next is to it's a large area with different surface types. So first of all, we are going to sample some points that we'll visit on the field, and then once we visit this point on the field, we're going to label them, because when you go to the field, you see the point and you label it. But in this prac, you're not going to go in the field, right? You're going to assume that you are out there in the field and then label this point. But first of all, let's sample this point. So we did something like this in the last video. where we sample 500 points. But in this case, we're going to sample. So you call the sample function, and this is our image. So you can see that this is our image that we've produced, Sentinel-2 project area. So that image here, and then we're going to sample. We call the sample function, and we define our region of interest. So our region of interest is the project area, which we already have covered upstairs. You can see this is it here. So that is our project area. And then the scale of this Sentinel-2 image, we're going to use 20 meter. That is the worst it can be, 20. And then we are going to sample 120 pixels. So we're going to sample 120 pixels. The more pixels you sample, the more likely your results will improve. But in the interest of time, we're only using 120. So we're asking the computer to sample only 120 pixels from this huge amount of pixels available in this image. And then we are going to set the seed to be any number, which you can change this to 888. You can change it to 000. You can change it to 15, or maybe 30, 13, or 77, any number at all, or you keep going, just that you have to be consistent. So once you choose a number, you have to be consistent. And why do you use this number? Because the process is a random process. When you put this number in and you rerun your code, you are going to produce, or you are going to allow the computer to produce the same set of values for you. You don't want to run and then you see different numbers than the previous. You may not want that. So if you want to control the computer, you just put any number here to the seed, and then the computer will say that, okay, anytime I run this, I'm going to generate the same numbers for you. Okay, so to have consistency. So that is why we selected this. And then we want to see the coordinate, the latitude and the longitude for every pixel that is selected. That is the 120 pixels they're going to select. We want to see the coordinate of this. So if you, for example, zoom out, you see these are the pixels. You can see this is one pixel, another pixel. And you see these are pixels, right? So these square pixels here, that is a lot. Even with this small region of interest, that is so many. But in all of this, we're going to select only 120. And for every pixel you saw there, we want the computer to tell us the latitude and the longitude, so the coordinate. So that is it. And then you print this to the console, and this is going to result in a filter collection. So that is what you're going to see there. And then in this case, we want to visualize this selected pixel. So you're just going to run this, right? So you can see that these are the 120 pixels out of the lot. You can see. So if you zoom out, okay. So this pixel has been selected. You can see that this pixel has been selected. So now you will take these results and go out to the field, your project area, and every pixel you see on the ground. So this pixel, if you see it on the ground, you have to tell what color type dominates the pixel, and then you give that name to the pixel. So let's say this is a bare ground, okay? So bare soil. You go there and it's dominated by bare soil. You're going to call this bare soil. So these 120 pixels you've collected, they are actually locations in space that you have to take your GPS coordinate and visit these places and then identify. So this is like artificial surface. This is a road that has been created, or maybe it is not even a road. It could be, it's not even a road, So you always have to zoom in to see the pixel. Yeah, you can see that it could be like vegetation, and then you label it, okay? So like I said earlier, you're not going to go out to the field to do this. So we expect you to use your background knowledge and, your more of like common sense, to really label this. So now we have got 120 samples and we have to label each one of it. And this is what we are going to build on, okay? Well, so we got 120 pixels, and every pixel you are now going to say whether it is a natural terrestrial vegetation, NTV, or it is natural aquatic vegetation, natural bare surface, and so on and so forth. So every pixel in that 120 pixels, you are going to give it any of these labels depending on the dominant surface types the dominant surface type you see in the image, okay, or in that particular pixel. Well, to do this, you have to use the add a marker or this drop point. So once you click here, and then you have to go through all of these 120 points. So I may start from here. You have to zoom it all the way until you see that 1 pixel. Yeah, so this is the pixel. So I'm going to drop this marker here, and then I'll go and call this here, and I'm going to call it's a natural terrestrial vegetation, so NTV. And then I'll change this one to a feature collection, and I'll click label, and then I'll put label here, and I'm going to give it a value of 0. And then maybe if I want to change the color, I can move it here and then maybe slide it depending on. So this is optional, you can leave it. Then I'll click OK. Then I'll go take my hand button, zoom out, find the next pixel. So I now have 119 pixels because I've labeled 1 pixel out of the 120. Also, this is the second one. So this is the pixel here, and I'm going to take the marker, the point here, and I'm going to drop it here. And again, I think of this as NTV, so that is it. So I've sampled to NTV. Okay, I'll go to the next one, and let's say I go here. This is my third point, and then clearly this is artificial surface. So because it's a new class, I have to go to new class, new layer. Just click this one, and then I pick my drop point here. I drop it here, and so this is a new class. So I'm going on new level. So I click on the and then I change this to that, and then I keep the name label, and then this is a new label. So I'll just make this one 1, and then here is artificial surface, which is AS. And then if you want to change the color, you can change that. Then I put that here, and then I take my hand button and move on to the next sample. So let's say I come here. So again, this is I'll consider this as a natural vegetation. So here I'm going to click on this one here, and once I click on this, I activate it, and when I pick the point here, I can add it to this, and now you got 3 points, for the natural terrestrial vegetation, and then 1 point for this. So it means that in all you have done 4 out of the 120, and then you keep going. So take the hand button, then go to the next pixel. So find the next pixel. So these pixels were randomly selected by the computer. So let's say I want to get a different class. So if you look at this point, this sample point is a built up area. So again, it's going to be considered as artificial surface. So you're going to click on here. Then once take the point and just put it there. So now we've got 2 points for artificial surface. So you do that until you finish all the 120 points, and then you know that you have labeled them, okay? So once you have dropped the points, label all the 120 pixels, you have to review to see that some of the pixels have sufficient number of samples. So one of the things you have to do is that if there is a class that doesn't have sufficient points, so sufficient means that a class should have a minimum of 50 points. So that is a rule of thumb. So where you have a class that doesn't have that many points selected by the computer, you can manually add to them. So for example, if you don't have 50 points selected for water, you can manually go and say click here and then select 50 points for water. So you may select 1, 2, 3, 4, 5, and so on and so forth until maybe you add 10 more. Maybe the computer selected 40 points and you need 10 more points to make it 50. And then, or maybe the computer selected 45 and you need 5 more points. And so you selected this additional points that the computer didn't select. And then you go back here and then you change this to feature collection. And then you label it. And then if it is 2 for water, you just keep it. And then here you just call it water. Okay. So then you create this additional data onto that. Okay. So that is how you can create additional points to meet a class with 50 pixels. That is what you can do. So once you have got every class covered with minimum of 50 points, you are now going to merge your features. Okay, you are now going to merge your features. So I'll be scrolling down here, and then I'm going to merge all my features into one. So I'm going to merge. So I'm going to merge the natural terrestrial vegetation with the other, just to create a feature collection, and then I'll just run that. Okay, so you put all of these feature collection you created into one. So instead of have different feature collections standing alone, you put all together to create one big feature collection. That is what you have produced here. Okay. So when you go to your console and you click on the feature collection, so you could see that I have 183 features instead of 120 because I collected additional 63 features because there were some of the classes that didn't have many pixels selected for by the computer, so I manually added 63 pixels. I didn't demonstrate this through this video, so you may not see that, but I explained earlier that once you are not happy with the number of pixels each class has, and the rule of thumb is that a class should have at least 50 pixels. So you can collect additional pixels, and that is what I did. And then I have 183. Okay. So what I'm going to do next is that I'm going to merge some of the classes, because some of the classes are really minor. They are rare classes. So I'm going to merge some of these classes. So for example, just to explain here that we label water to be 0. And so this is if you label water to be 0 and the natural terrestrial vegetation to be 1, artificial surface to be 2, and then natural surface 3, and then the natural aquatic vegetation 4, and then the cultivated terrestrial vegetation 5, right? So what we're going to do is that we are going to merge. So at the moment we have got 6 classes, but we are going to merge some of the classes so that we are going to have 4 instead of 6. Okay. So what we can do is that we can merge the natural terrestrial vegetation with the natural aquatic vegetation. So we merge these 2 classes into one, and then we're going to merge the artificial surfaces and the natural surfaces into another class. So we are going to end up with 4 classes. Okay. Well, so we're going to merge our features, and we have to find what data type that one is. So if you go to your cover types, that is a feature collection. You can see that is a feature collection. This is a feature collection. So we are going to go into the 2 boxes, and then we'll go to feature collection here. And then what we're going to do is that we want to remap. So the method we are going to use is called remap. So that is going to be this one here. I'm going to put that one here. So I'm going to put my mapping values, which is 0 for water, 0 for water, 1 for NTV, 2 for artificial surface, 3, 4, and 5. So this is that. Now I don't know the lookup out. So what is that one? So I need to go back here again. And then I'm going to be, oh, that is also a list. So, well, if it's a list, then I'm going to bring my square bracket around that. And then I go in again and says, that is what the output mapping values. And this must be the same size as the look up in. So we go 1, 2, 3, 4, 5. So it should be the same size. It also have like the length should be 5. So what I'm going to do is that I'm going to merge. I left water untouched. So here water is untouched. And then one is what? One is NTV. That was also untouched. And then 2 is artificial surface. Okay, so two is artificial surface. So that I'll also give that one 2. And 3 is natural surface. So we combine it with artificial surface. So instead of writing 3, I'll write 2. Why? Because now we think the 2 and 3 are 1. So we have to give them the same number. Okay. And then the next one is 4. What is 4? 4 is the native aquatic vegetation. Well, we are combining that one with the native terrestrial vegetation. And at the moment, the native terrestrial vegetation is 1. So where we see the NAV, we have to assign 1 there. And then the CTV is left untouched. So that will be 3. So you can't write 5 because it should be in order. So 0, 1, 2, the next number should be 3. You cannot write 5. Okay. So you're going to get 0, 1, 2, 3. So that is going to be 4 classes. So we're moving from 6 classes to have 4 classes. And remember, our column name is label, right? It's label. You can see it from here. It's label. The column name, sorry, the column name is what? Label. So we call it label. So here, in that should be what? I don't know what that one should be. What data type should it be? It should be a string. So it's going to be a string, which means I need double quote. I'm going to put double quote here, and then I'll type in label, okay? So once you are done with this, what you need to do is that you have to finally sign this to a variable. So I'm going to I'm going to repeat the name, and so just place the name here, and then assign this right hand side is the one we created, and maybe we're going to distinguish this name here from that by putting 2 in front of it. So I'm going to do that, and that is what I have done there. Okay. So the next thing we're going to do is that we are going to assign, or we are going to create reference areas. And what does that mean? So we have 183 pixels, and all 183 points. These are actually points. If you look at it, you can see points. So we have 183 points. And so we have to connect our image. So if you go up here, this is going to be our image. So our image has got some bands. We selected about how many of them. We selected here how many bands. We selected 1, 2, 3, 4, 5, 6, 7, 8, 9 bands. All right. So we now have to assign these 9 bands to every single image. Okay, every single point that has been selected. So we're going to create reference areas by sampling our image. So that is what we're going to do here. So this is to create what I call training areas. So we create the training areas, and the way to do it is that you take your image and then you're going to sample from your image, and we're going to use our feature collection, the training points we have labeled. And then once you have done that, the properties is a label, and then the pixel size is 20. And then, so these are going to be your reference points. So now every point will be associated with 9 spectral bands. Okay, so that is what you have created there. I'm going to run that. And then you go to your console and find what is called reference point. So this is what you have got here. So you go to features for that. Yeah, you go to features, then you can see properties, and see now you got your bands. The earlier one you did, when you go to features and click on features and properties, you don't have the bands. Okay, you don't have the bands. But this new one that you have just done, you can see that comes with the bands. All right, so that is what you have done. So now every point is now connected with the spectral bands, and that is what we call the training areas. Okay, or sometimes the reference point. So that is what you have done here. So the next thing is actually now going to build the classification and regression tree algorithm. So we are going to now bring in the classifier, and then train the classifier, and then assess how it performs on all the pixels. Okay. So we train part. So this is a supervised classification. So you have to go to docs here, and then go to classifier, and we are going to find one of them, and that one is the CART. So it is this one here, the classifier.smart. So this is what we have here, and we're going to use that. So this is the tool we're going to use. So you need to know what the max nodes, then the other arguments, what are here. Okay, so based on the information we have got here, we're now going to now create that. So what we're going to do here is that you saw that this the classifier here, that is it here, and then we put nothing here. It's empty. So we're not going to use the arguments. So if you integer the maximum number of leaf nodes, we're leaving all those ones empty for now. And then we're going to train it. So this is the classifier. We are going to train it. We are going to train it with the points or the sample point we have labeled because we are very confident about it. We know our environment. In real life, you may have visited the site and then see the dominant surface types and therefore use that to label site. So now you are going to train that. So you see that we call the train function here. This is a train method here. And so you're going to train that and see which is our reference point, the one that we saw on the field. So what we call the ground truth, and then label. And then what are the predictor variables? The predictor variables are the 9 spectral bands. So that's what we're going to use for that. And then we're going to run that, okay? So I'm going to run that and nothing is really going to pop up until we complete the process. Well, now that we have created our classifier and trained that, we have to apply it to our image. So what is our image? Then our image is given to us here. So this is our image that we clip to the study area. So I'm going to copy this image. And so what we're going to do is that now classify every pixel in the image. So we have to bring the image. So we bring the image here, and then we are going to call the classifier, the classify method. So whenever you go to ee.image, you have to look for this method here, classify. So it's a method, so you have to go to C. So that is it. So this is a method we are calling. And then the argument is that we want to put in the classifier. This is the classifier we define here. So we are going to call this classifier, which is the CERT algorithm. And then we're just going to stick it here. And so we're going to now assign this to a variable. As you always, you have to do that. And then we're going to call this variable this name. Then we assign that to that is going to T there. So once you have now applied the algorithm to your image, every pixel in the image is going to be classified. And the next thing is that you want to visualize it. Okay, so there's a next thing we need to do. So you're going to visualize the chart classification map. Okay. I think up to this point, we all know how to visualize an image or a point using the map.add layer. And if you haven't done that yet, please watch the previous videos because we've done it multiple times. We're going to visualize that. And this is a bunch of script that is going to do that. And just to explain, so this is our visualization parameter we define here. And then this is sort of you center onto your study area. So this is optional. Always take it out if you know the study area it's not going to, if the Earth engine is not going to take you somewhere else, say US, and it's definitely going to take you to your study area in Australia, then you can just leave, you can specify this, otherwise this is not. I'm just going to leave it. I covered this in the last video, so be sure you watch it when we are doing the unsupervised classification. And then once you have defined your visualization parameter, minimum is 0, maximum is 3, because we are dealing with 4 classes. Okay, so 0, 1, 2, 3, so 4. So 0 is going to be given purple, which class is 0. You have to go back. The water, yes. And then class 1, which class is 1, that is will be green. Purple will be 2, and then light green will be 3. So blue is water, green is going to be the natural terrestrial vegetation, purple will be bare land, which is essentially a combination of natural surface and artificial surfaces, and then agricultural areas, which we normally call the cultivated terrestrial vegetation, that is going to be light green. This image. So that is the explanation of the legend here. So now we are going to apply it, and then we call the almighty map.add layer, then and that. Okay. Well, once you do that and you go back and be sure you turn off all the layers underneath the final layer, which is your classification. So I'm going to turn off this one. The geometry points we collected, I'm going to turn. So this is going to be your final output, and this is the classification of all the pixels using the classification and regression tree algorithm. So that is the approach here. So this is water. It's doing well for water and it's doing well for other surfaces, but this is all visual. So always you may want to turn off this background satellite imagery on and off, and then see. Alternatively, you can just keep it up and then turn on your original image, and then visually examine the performance or assess the performance of this classifier. So it does well for water, and this one here, which one is purple, and so on and so forth. So this is just up to you to visualize, to visually assess the quality, because we'll get the chance to quantitatively assess the performance of this algorithm. Okay, so in the next video, we'll be exploring random forest classification and then compare the two visually and to see which one is performing better visually, and then we get the chance to now look at it quantitatively instead of qualitatively, see some numbers using error metrics. So I would like to wrap up by saying that this is the results for the supervised classification using classification and regression tree algorithm, and in the next video look at random forest. I hope you find it useful. I'll see you in the next video.